Right, let's go to the next application, which is the radioactive decay. So let's read the question here. The rate of decay of a certain radioactive material is proportional to the mass present at time t second. So this first sentence here is very important. This will be your first your equation, your very important equation, because the word rate here, the word rate is enough to tell us that this will be the dt of what? Of a certain letter that you let them. So I choose the letter R as the important letter for me to put the R here, because I'm trying to calculate the rate of the decay of this radioactive material. So I choose the letter R. You can choose the letter D, whatever you want to choose, D or M, whatever you want to choose, but make sure you choose only one letter. Okay, so I use the letter R as the mass of the radioactive material. Kenapa dia adalah mass? Because we calculate the material by using the mass, means dalam bentuk gram. Okay, sebab dalam soalan ni saya nampak gram. That's why this R means the mass of the radioactive material at time t. And so how is the equation then? So the equation is the rate of the radioactive decay is directly proportional to the mass. Okay, to the mass, since the R is the mass of the radioactive decay, and so we put R lah, we put the R here. But why do we have negative? This is special a bit. In the previous video, population growth, there is no negative. Why? Population growth means the growing number of people, means it positive, right? It's positive. People is bertambah, jadi dia positive sign. While this one is radioactive decay. The word decay is enough saying that it is reducing, Decay means reducing. So when it is reducing, it means negative sign. Reducing, okay? So you jangan takut. The negative sign here means the mass is reducing. Okay, the mass makin berkurang dan berkurang, sebab itulah untuk bahagian application radioactive decay kita kena letak simbol negatif. Okay, ini wajib. So this one you will get the first mark. Okay, sorry. The first mark is not there. The first mark is not directly proportional. The first mark is where dr dt is equal to the negative kr. Okay, so this is your first marks. Okay, so basically step di sini adalah di mana you perlu hafal sajalah. Kalau tak nak pening, hafal saja ini untuk radioactive decay. Okay, radioactive decay starting dia sentiasa equation yang begini. It's just that you have to name whatever radioactive materials that you want to name them. In this case, dia pakai mass lah. Okay, so R is the mass of the radioactive materials that is decaying. Alright, so basically satu markah dah dapat sebab dah pandai keluarkan equation. And then next one, what we have to do is go on separate it by using separable variable. The knowledge of 3.1, use the separable variable, cross multiply, and then you will get 1 over r dr, and then here you will get negative k dt. So this thing is almost the same as the population growth, right? Yang berbeza hanyalah pada negative sign sahaja. And so now we are ready to integrate both sides. So we integrate both sides, we will get ln r here, and on the right hand side, the negative kt plus c. And then we will exponent both sides to do what? So that we will get only r. And then you understand this by using the rule of indices. Okay, sebabkan sini plus, sini akan jadi times, and therefore my final conclusion, my general solution is just RT is equals to A exponent KT, where A is my exponent C. So we do not want to use exponent C. Kita tak nak. Sebab itulah kita tukarkan dia jadi huruf A. Sebab dia lebih mudah dikira dalam bentuk huruf A. So our job is to find this value of A and this value of K. Okay, that is our job. After getting the specified equation, means after you have found the general solutions, means let's go and found the A and K so that we got the particular solution. So we gotta have the first info lah. So according to the question, it's given at time t0. T0 means the initial time is 0, where you read here the mass is initially, see the word, the mass is initially 80 gram. So the word initially means the time t0. So perkataan ni sendiri you kena faham bahawa time dia kosong. Jadi buatlah information di sini. The first info here, write down that the first info, it means it is given to us at time t0, the mass is 80 gram. Kalau you nampak betul-betul cara penulisan saya letak R and then saya letak 0 di dalam bracket ini. It means that at time t0, the mass of the radioactive material is 80 gram. Okay, tulis dalam bentuk penuh supaya senang semua orang faham. And then I just sub in the 80 gram into the general solution here, 80 here, and then put in the value of T0 there. And so I got my A value is 80. So actually by having the first info, you akan sentiasa dapat nilai A. Benda ni pattern sama je, apa-apa application pun. You will always get your value of A first. That is the very first important thing here after the general solution, okay? So then after you dah dapat value of A, 80, you just masukkan saja ke dalam this particular solution. You will get RT bersamaan dengan 80 exponent negative KT. So you have got your A, now you got to find your K. So how do you find your K? Your K, in order to find this K, you must have the second information. Second information say that at time t 50 second, the mass is 60 gram. Oh my dear, how do I got 60 gram? Mana ada perkataan 60 gram dekat sini? So, how do we do it? So it is actually at time, read the question first. It is observed that only 75% of the original mass remain after 50 seconds. So sebenarnya R50 at the 50 second, it is from the original mass, which is 80 gram, darabkan dengan 0.75. 0.75 disebabkan inilah 75% of its original 80 gram there. It will give you 60 gram. That is why I got here 60. Okay. At 50 second, the mass is reduced from 80 gram jadi 60 gram. Nampak tak? The reducing. The mass of the radioactive material is reducing from 80 gram jadi 60 gram setelah 50 saat. Okay, so this is itulah kefahamannya dan kita tulis secara matematik. Okay, and so when we got this second info, this is the second info, guys. After we got this second information, we sub in the mass 60 gram here, and then we sub in, no, that is the things that you sub in 60 gram ke dalam general solution, you all. Okay, ke dalam general solution yang sudah berjaya dapat value of A, which is 80. And then you solve, you dapatlah nilai K. So you dapat nilai K which is negative 1/50 ln 3/4. So again, you boleh tulis dalam bentuk penuh ataupun you dalam bentuk points. Dua-dua boleh, but make sure you take 4 to 5 decimal places. Take more. Alright. And then after that, you tuliskan balik supaya everything here sudah pun menjadi bentuk particular solution. So over here is your particular solution. So this highlighted one is the particular solution. Tapi kenapa banyak sangat steps? Sebab pada asalnya dia mempunyai negative. So dalam K kita juga ada negative. So negative sign bertemu negative sign, dia akan jadi positive sign. So I simplified this so that it will be written nicely there. My particular solution looks very, very beautiful there. Okay. I mean, conceptually perfectly there. Okay. So what's more to do? Apa yang diminta? So we have already answered the first question. We express the mass at time t. Kita dah jawab dah pun tadi. Inilah ekspresinya. This is called the expression of the mass at time t. Move on to question B, which is find the time taken for 50% of the original mass to remain. Apakah maksudnya? Find the time taken, which is we do not know the t, what is the time t second, for 50% of the original mass to remain. Apakah selebihnya berat radioactive material tersebut? Tapi dia kata 50% of the original mass to remain. So apakah selebihnya lah? Jadi kita kena cari find the value of T when the radioactive, when the mass of the radioactive material is 0.5, which is the 50%, times with the original mass. Okay, 5 times the original mass, which is the 80 gram. Original mass is the 80 gram kan? So we got 40 gram. So kita kena cari apakah masanya di mana mass of the radioactive material is 40 gram. So we take back the particular solution. We use the particular solutions from A, question A, jawapan daripada A tersebut. Kita masukkan gram kita, 40 gram. And so we can find the value of T successfully. So sangat senang saja solve this mathematically. You will get 1/2, blah, 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 until you get the value of T. So T here is eventually 120.5 seconds. So you can write like this, or you make a conclusion. Please write down the conclusion saying that the time taken for the 50% of the original mass to remain is 120 seconds, 120.5 seconds. So take whatever points you have there, 47 pun boleh, 5 pun boleh. So up to you.